There's going to be only one lecture left in this track, and unfortunately it's going to be the end, but still we are ahead of this talk and it's not the end. Please remember about rating the lectures, please remember about giving the comments, and then please leave the feedback for the whole conference. How did you like it and what to do next during the next offline edition of JDD. And it's my pleasure to welcome Magda on the stage. Magda, the stage is yours, and I will be back here after your talk.
Thank you. It's a pleasure for me to be able to talk to you today about implicits and Scala free. Now, I have been a Scala developer for 5 years now. And right now, I can say that Scala is a great language. I enjoy writing it every day. But the beginnings, they weren't so smooth. I kept struggling to understand various concepts of Scala, and for sure, implicit was one of them. There were times where I thought, okay, I got this. I understand implicits. And then I came across some other usage of implicits, and I was lost again. And I kept coming back to my more experienced colleagues and asked them, okay, I know we have talked about implicits, but can you please explain it to me one more time? What happens here in this different usage? Fortunately, my colleagues were very patient. So I got through this difficult phase, and I'm a happy Scala user today. But I kept thinking, why does it have to be so hard? So when I heard about Scala free, and I heard that in Scala free the concept of implicits was going to be totally redesigned, I was curious. I wanted to learn more. So this is how this presentation came to be. I would like to share with you what I have learned. The plan for the next 40 minutes is, at first, I will tell you what implicits are, why you should really care, and why you would need it, why they can be so difficult and confusing in Scala 2, so the existing Scala, the previous Scala, let's say. And then the main part of the presentation is I will show you 7 use cases of Scala 2 and Scala 3 code to explain it to you how it's different and how it's better, hopefully. And then I will finish with a couple of words about migration. If you have any questions, then you can just ask them in between and interrupt me. So let's begin by saying what implicits are and why we need them. Well, the implicit keyword in Scala it's a keyword which can mean very different things. And you can find it next to various language constructs. But what's common is that it's needed to provide so-called contextual abstraction. So you can use it to define abstractions about your context. Because when your code runs, it doesn't run in void. It runs in some context. And for this reason, you don't have to specify everything explicitly, but some of the things you can say, this is your context, so the compiler can infer it from you somehow for you. And apart from providing context, which is just a general, let's say, term, it can be used, the implicit keyword can be used to add functionality to your code, to define type classes, which in itself are a very important and powerful feature of the language, to provide implicit conversions between the types, even to solve the problem or the issue of dependency injection, to express capabilities about the code, to compute new types, and to prove to your compiler that some relationship between your types exists. So implicits are also very widely used. It's widely used in Scala code and also in libraries. You will often see that if you want to use some library, you have to somehow use implicits. So implicits make us powerful. But unfortunately, they also sometimes make us miserable. And one of the reasons why this is so is that you can find the implicit keyword next to various language constructs. So we can have implicit parameter, implicit argument, implicit value, object, method, and class. So it's not like you see the implicit keyword and you instantly know what is happening in the code. No, you have to have the experience, you have to know the idioms, the patterns, to see what is really being defined here. Is it the implicit conversion, or maybe is it providing context, is it something else? So you never know instantly. And another problem is that sometimes you have a piece of code in Scala, it's working, it's fine, and then you copy a bit of it, you put it in another class, and then it doesn't work. The compiler is not happy, and you don't know why. And personally, I have spent hours trying to find it, and in Scala, often the problem is that you are missing the right implicit import. It was somewhere there in the base class, buried in 20 or 30 imports. You don't know, but when you find this magical one line, you copy it along, then finally the compiler is happy. So it almost feels like magic when you find it. It's like this magical import incantation. On the other hand, sometimes you import too much, because sometimes maybe you don't even know that one of the imports here defines an implicit conversion between the types, so that suddenly your compiler treats some code as some other code, and weird things happen, and you don't even know it. So for all of these reasons, I think this may be the reason why Scala can be considered a little bit hard, a little bit confusing, and maybe has a steep learning curve. So where does Scala 3, what does it bring to the table? Now, Scala 3 is a major language rewrite. It actually took 8 years from the first commit of Scala 3 to the actual release. But what's very important for me is that the creators of Scala 3, they have listened very carefully to what we are saying. They have watched the code that we write. They have listened to our comments and our issues and our complaints. And one of their main goals in writing the new release of the language was to find and fix the tricky bits, the pain points, to make the language more concise and more expressive at the same time, easier to work with. So it's probably not a surprise that implicits have been identified as one of the main pain points, which needs fixing. And it was fixed to the point where the implicit keyword is just gone from the language. It doesn't exist there at all. What we get instead is we have a couple of new language constructs which have the important feature of doing one thing and doing it well. So right now I will show you 7 use cases. It will be providing context, adding functionality, defining type classes, providing implicit conversions, and I will say a bit about imports, unused names, and compiler errors. And these are the 7 use cases, which are probably not a complete list of differences in terms of contextual abstractions between Scala 2 and Scala 3, but these are the ones that I consider the most important or the most practical or the most widely used. So let's begin with providing context. One of the things that you often do in Scala, you want to do something asynchronously, maybe you use a future. So this is what you are really interested in. You just define the body of the future. But you know that this is not everything, because if you want to do something asynchronously, you need to have some kind of thread pool or something like this. So in Scala, this is execution context. And here at the top, this is the definition actually of the apply method when you create the future. So you can see that apart from having the first parameter list, the body, you also have a second parameter list where you provide the implicit argument of execution context. And if you want the bottom code to work, you need to have a bit of code like this. So somewhere in your code, you have to provide this context. You have to provide this execution context that you want to use for this future. And this is Scala 2. This is how you used to do it. So now let's see how it's different in Scala 3. The bottom code is the same. But when you look at the definition, you see some new keyword. And this is this using keyword. So it says that this method is defined and it needs to use an executor. And where you provide the executor in your code, you use the given keyword. And this is one of the main changes in the sense that you would probably use this pair a lot. So it's not implicit and implicit, it's using and given. And you'll also see it in later parts of the presentation. The second use case is adding functionality. So To define it, let me introduce a sample domain. So let's say that we are in the business of a reading website. It's a social website, you add books that you have read, and there's also this nice feature of reading challenges. So let's say that users can add the books they have read, but also in January they can specify, this year I want to read 6 books or 12 books or 20 books, and then you see during the year if you are on track or not. But let's say that we want to introduce a change because it turns out that some of the users are inserting really short books, like 5 pages long. And they then finish the year challenge in January, and it's not so much fun for everyone. So we want to introduce a new method on the book type, which is our domain type, to say whether or not this book qualifies for a challenge. Unfortunately, this book type is closed type. We don't have access to it. We don't own it. We cannot simply add the method there. Maybe it's in some hidden package. Maybe it's just a type which doesn't belong to our team. So what do? In Scala 2, or generally, we need to add this method. And in Scala 2, you use implicit class for that. So this is how you do it. You define an implicit class. You need a name, even though you won't really use it. It operates on the book type. And here you have this qualifies for challenge method. The body of the method is that if the book is longer than 20 pages, it does qualify. And right now, even though I haven't made any changes in the book type, I can have the code that is there on the bottom, at the bottom. So this is Scala 2. And how is it different in Scala 3 if we don't have the implicit keyword? So we cannot use the implicit classes. The bottom code is the same. The book type is the same. But what you see is the new keyword, extension. So in Scala 3, there is a new language construct added solely for this purpose. So this is called extension methods. You write an extension on the type book, and then you define the method that you want to add to this closed type. And this is a great example of how Scala 3 adds constructs which do one thing and do it well. So right now, if you see this extension keyword in your code, you instantly know what is being defined. You even don't have to think. You know that it is adding a method to an existing closed type. So this is great. And now, let's look at type classes. Type classes is generally a very powerful feature, but it's not easy. For me, it wasn't easy to understand them. So to say why you would really need it, let's consider another example in our domain. Let's say that some of our users say they don't really read so many books, but they read a lot of articles in the internet. And they would also like to take part in the challenges. But how do we score it? Reading 10 books isn't the same effort as reading 10 articles. So we want to, apart from the book type, have an article type, and we would like for them to be treated differently. So we would like to have a score, and if you add a book, then it's scored according to the number of pages. So for example, if you read Dune, you get 600 points. But you also have the article type, and if you add an article to your reading challenge, then you get just 1 point for each article. How can we achieve it? Well, if only book and article had a common parent, then I could add a method to the parent, and each of the types could have its own implementation of the scoring method. Unfortunately, these are two totally unrelated types. So what can we do? And this is where type classes come in. This is a way it's called ad hoc polymorphism. This is a way to add behavior to unrelated types. So what you do is you define a trait. Note that this is still Scala 2. So you define a trait, in our case scorable. It defines the behavior. It is typed by whatever type we want to support here. And there's one method scoring of that type. And the implementation of the type class is the implementation of the behavior. In Scala 2, you can achieve it with implicit val, object, or def. But generally, it's the implementation of this trait parameterized by our type, and the definition of the score method. For the book, it's the number of pages. For the article, it's one. and the way you use such a type class. For example, here you have the current score case class, which takes the current value of your score, and the add item method is defined on the T tab. And what you see here, this T colon scorable, it's called a context bound, and it means that it operates on a type which has this scorable behavior, any type which is scorable. So it takes the item and it takes the current score, and this implicitly of scorable, what it says to the compiler is, dear compiler, please just fetch to me the current or the actual appropriate score method according to the type that I was called with. So if we have this, then we can have the code on the bottom, which is if you add a book, you are scored in a different way than if you add an article. And this is generally why you would need a type class. Now, this is one way of defining type classes. Another one is a bit different. So here at the bottom, this pointer doesn't work. But generally on the bottom, instead of the context bounds, you can have another parameter list with the implicit scoring. So you actually have the name of your instance. And instead of this implicitly keyword, you just call it by name. So this is just a matter of taste. And now we are moving to Scala 3. And in Scala 3, type classes are defined using the given keyword that you have already seen. So you have a given scorable of type book with the implementation and a given scorable of type article. And the way you use it, you can have, again, the context bounds here. And here at the bottom, you will see the summon. So it used to be implicitly, now it's called summon. So even for such a simple thing, the implicit keyword is gone, even as a prefix. The behavior is the same, but it's not implicitly, it's summon now. And if you prefer the other way of writing this, then you can also use an implicit parameter list with this using keyword and use the score by the name of the scorable behavior. So these are type classes. The next use case are implicit conversions. Why would you need an implicit conversion between the types? Let's say we have our books and we would like to print them, display them to the user. And we have this excellent print method somewhere. It's this unique, beautiful way of printing, and we would like to use it. But unfortunately, it only operates on the item type. And we cannot add anything to the item type. We cannot really add anything to our book type because they're closed types. What do? We would like to tell to the compiler that if you see a book, we want to print a book, we would like it to treat as if it was an item. So in Scala 2, you used implicit defs, so implicit method for that. You provide a method operating on the book type, on the source type. It returns the target type, which is the item, and the way it should treat it, it should just invoke the constructor of the item and take the book title. So for Scala 2, that's another use of implicits. In Scala 3, to achieve the same thing, you have this special conversion class. So this is actually something that comes from the package out of the box. It's scala.conversion. It's a class parameterized by the source and the target type. So in our example, book and item. And it has this one apply method which you need to define or call or specify. So in Scala 2, the problem is, because it was an implicit def, maybe you could just not notice that you are defining an implicit conversion. And Scala 3 makes the conversion more explicit, because you have this Scala.conversion type. So every time you see this type, you know that what is happening here is you are providing a way for the compiler to implicitly go from one type to another, according to your definition. And now let's say a bit about the dreaded imports. So generally in Scala 2, a code like this would work. So you just invoke the future with the body, you have some magic incantation, it works. In Scala 3, it doesn't compile anymore. Why? It's because this implicits.asterisk, what it does is it says, dear compiler, please fetch everything to me apart from the given instances. So if you do want to import given instances, you need to use this syntax. So this implicits or package name.given. And then the code will compile. And the advantage of that is that next time you will copy the code to another class and it's not working for the compiler, you can see that in the old class or in the base class, you have just a couple of imports which end with the given keyword. So you know that these are your candidates that you may be missing and you may need to copy for the code to work. So it's almost as if it's making the implicit imports much more explicit. And if you do want to import everything from a package, you have to use this syntax given, comma, asterisk. And then it's really importing everything. But it's still explicit enough for you to be not confusing. The sixth one is one of my favorites. It's about the names. You know that naming things in programming is a difficult problem. So at the bottom, we have a sequence of books. We have 2 books, and we want to display them to the user in a sorted way. So because we don't want to reinvent the wheel, we would like to use something built-in. And this built-in is what's at the top. So we have this secobstrate, and it has the sorted method. If only you provide to it, in Scala 2, an implicit ordering of your type, it will work for you. Because, of course, out of the box, the compiler doesn't know how to sort books according to the number of pages or according to the title. We have to somehow provide it. So how you provide it, you already know. In Scala 2, it's an implicit val. You provide the ordering of type book, and your definition is that for the 2 books, you just compare the titles. And here, you can see at the bottom that this by title name is not used anymore. Because what the compiler really needs are the types. But still in Scala 2, you had to come up with this name. And in Scala 3, you don't have to do it anymore. So here you will have this using and given pair, and you can use the name if it adds anything to your code, if it makes it more readable, but you don't have to. So it's not a big thing. It's just a small thing which makes your life, everyday life with Scala, a bit easier. Because you don't have to decide on the name. Because what do? Do you provide a meaningful name? Or do you provide a one-letter name? Do you use some convention in your team? These are the decisions that you don't need to make. Sometimes you just need to omit the name, because it's easier. And the last point, the last comparison, are compiler errors. In Scala 2, if you had some import missing, the compiler was a little bit helpful, but not too much. So it said to you that it could not find an implicit value for the parameter called evidence of this type. But in Scala 3, apart from that, it also tells you actually what you need. So sometimes where it's needed, actually. Because sometimes if you have a long chain of methods, you don't even realize which of them needs an implicit parameter. And here, this is very, very concrete. It tells you the method name, the parameter name, and the class. And if that's not enough, sometimes the compiler will try to be extra helpful for you. And it will actually suggest the import that you might be missing. When I was trying it out, and I always miss the parameter, the implicit import, it almost felt too easy. It felt like magic, because the compiler already knew what I was missing. So I could just add it and go on with implementing the feature, instead of being blocked and stripping and losing context, because what was this implicit path again? You don't know. Of course, not always it will work perfectly, but sometimes it will, and it will make your life easier. So now that we have the 7 use cases, let's say a bit about migration. Because, as I said, the implicit keyword is used extensively in Scala code and in the libraries. So how do you migrate if the keyword is not supported anymore? Do you have to just rewrite everything from scratch? And do you migrate your code first, or do you need to wait for the library to migrate first? In Scala 3, we will have a grace period. So at least for 3.0 and 3.1, both will be supported. So for example, if your library has already migrated and it uses the given and using pair, your code can still use implicits, and it will just be translated to one another without a problem. So they can be used interchangeably also in your code. And also you can migrate first and use a library which was prepared for Scala 2 or is still using implicits. That's fine. So now, to sum up, the most important thing in Scala 3 in the context of contextual abstractions is that now the code will convey the intention and not the mechanism. So you will write in your code what you want to achieve and not how you want to achieve it, which is actually along the functional programming principles. So with the new keywords, which do one thing and do it well, the given and using pair, the extension methods, and the Scala.conversion class, when you add to it cleaner imports and more helpful compiler messages, writing contextual abstractions in Scala 3 becomes something which is easier, more pleasurable to write every day, and it's also less confusing if you look at the code, because you look at the code and you see instantly what the author is trying to tell you. If you would like to know more in the context of contextual abstractions, one thing I haven't mentioned is context functions. This is a brand new thing in Scala 3, and I haven't mentioned it because it doesn't have a direct counterpart in Scala 2. It's a completely new thing. But if you're interested in contextual abstractions, you should have a look at that. If you'd like to know more about what Scala 3 brings to the table and what other things it has identified as pain points or unneeded features of Scala and how it tries to fix it, the docs are very helpful and they guide you through all the changes. And when you are ready to migrate, there's a whole migration guide, where to start, which flags to add, and so on. So have a look at that. And if you would like to see the examples from this presentation, they live in a GitHub repository, two repositories, one for Scala 2 and one for Scala 3. So we can run them and try it out and see how they compare. Thank you. If you have any feedback, I would be happy to take it under that QR code or under that link below. And if you have any questions, I'll be happy to take them now. Yes? The question is whether Scala 3 is ready to use, right? Yeah, it's a tough one. I personally don't use it because in my project still I'm trying to get some services from Scala 2.12 to 2.13. But I would say that it depends on the tooling, but a lot of libraries already have support for Scala 3. So if your libraries are ready to go, then you are probably also ready to go. Yes?
Thank you, great presentation. When you mentioned the pain of learning that, I had the same pain. And what I was maybe missing in my knowledge was how to use IDE effectively to find that implicit somewhere along the Spark code. As an example, do you know if IDE actually now helps better to find this kind of middle part where this implicit is kind of defined? You remember you specified this first section above the expected result, but it needed implicit in the middle of your presentation. How to use IDE to actually find that real quick? Is there a good support in tooling for that?
Well, for me, the most important thing, I use JetBrains, IntelliJ IDEA, and for me, the most important is to learn the shortcut to show you what parameters, what implicit parameters are needed.
And you go to that, and then based on that, you navigate to the place on code.
Yes,
okay,
yes. So now if I have that, then it's more or less easy. But before I knew it, it was just like making your changes in the dark. I was completely lost without it.
I agree, yeah, thanks.
Any more questions? If not, thank you, Magda.
Thank you.